Good morning and welcome to Unit 10 Exponential Functions. Today we're going to be learning about long run value. Please make sure you take out a notebook to take notes during this video because there'll be a couple definitions you need to write down. And please pause the video as you go to try a couple problems on your own. Okay? So the video should take about 20 minutes if you factor in some notes and pausing. And then you're going to have about 30 minutes to work on your homework, which is worksheet number 3, long run value, which is posted on Google Classroom. Please make sure you pack up with about 5 minutes left so that you can get all the Chromebooks back in their rightful place. All right, so today we're going to look at limits. So your goal is to be able to use your calculator and algebra to find what we call the long run value or the limit of a sequence. And our big focus is going to be on the shifted geometric sequence, okay? So first we need to talk about a limit. So if you've ever heard the word limit before, it appears in like English and math, okay? So for example, how fast will humans be able to run? Is there a limit? So Usain Bolt's the fastest person in the world, and is there a limit to how fast he can run? I think most people would argue, yes, there's a limit to how fast he can run. So he can't get down to 0 seconds, he can't get down to negative seconds. So most things in life have a limit, okay? So when we're talking about sequences, the limit we refer to is called the long run value. So this is where I would pause the video and say, oh, I should write this down. So when I'm asking you to find the long run value, I'm asking you for in the long run, what is the value of the sequence going to level out to? Because it's going to have a limit of how big or how small it can get. A shifted geometric sequence is a new type of sequence we haven't learned yet. And basically, it's a combo of an arithmetic and geometric. It has a multiplied term and an added term, as you can see. Okay? So the first thing we're going to need is for you to grab your calculator because we need to learn some notation on your calculator. And we're going to use that to find the limit at first, and then we're going to show you the algebraic way. So go ahead and pause it if you need to write down any of these definitions. If not, get your calculator ready. All right, so on your calculator, the first thing you're going to do is hit mode, and you're going to go down to the word function and scroll over and make sure that it's on sequence mode. So hit enter so it's dark and blinking on sequence mode. And now you're going to go to y equals and you should see all of this stuff here, okay? N min is always going to be 0 or 1. That's whether it starts at U0 or U1. So if we look at our sequence right here, ours starts at U1. So that means our value for n min is going to be 1, okay? And then I'm going to clear this out because you guys need to learn how to type it in. So you're going to type in 0.8, and then second 7 gives you the U. So again, second 7, parenthesis. N is the one next to alpha. It's the xt theta n button. So n minus 1, and you need parentheses around the n minus 1. So right now we have this part written out. U8, 0.8 un minus 1. And then we're just going to type plus 10 on the end. And un min is our starting value. Our starting value in this case is 25, so make sure you have that at 25. All right, and I'm just going to hit second quit and get back to my home screen. Now there's multiple things you can do with this function. So the first thing we're going to do is we're going to go to second graph and get the table. So you can get the table of values ranging from 0 up to whatever value you want. Notice there's no values at 0 or negatives because the sequence doesn't have negative values. So there's our start of 25, and then it keeps going up for a while. Okay? The other thing you could do is you could hit graph. Now our sequence not showing up because we need to change our window, so I'm going to hit window. All right, so n min is your x-axis pretty much, or your u1, your 2, so it has 1 to 100. That's your un, like ours starts at 1. Plot start is at 1, plot step should stay at 1. That means you're starting at u1. My x-axis I'm going to have go from -1 to, let's say, 20. And let's just have it count by ones. My y-axis I know is going to have to be at least up to 25, but I know the sequence, if I looked at the table again, is getting bigger. So I'm going to go from 0 up to, let's say, 100 just to try it out. And if it doesn't work, we can always change it. I'm going to have it count by tens. So now I'm going to hit graph and see my sequence is showing up here in blue. It's kind of hard to see here. See that 100 is too big, so I'm going to change it back. Maybe we'll try something like 50. And you can see kind of how it's starting to level out. So I'm going to change my axis again, my x's. We're going to change that to like 100. We'll have it go by tens. And I notice this one's a little too big. So I change that to 60. And you can clearly see now how it's leveling out. This is the long run value right here, okay? And it's not really a straight line, just the points are so close together, it's making a connected line. But all sequences are just a series of dots, okay? So there's the graph. And then the last thing that's the most important thing is to hit second mode and get back to your home screen. Now I want you to find U6, U100, and U200. You could do that from your table, but it's a lot easier if you hit second 7 on your home screen and get the U. And I'm going to type U parentheses 6. That means U6. And that's going to give me a value. Then I'm going to hit second 7, 100. That's going to give me a value. And then I'm going to hit second 7 of 200. And if you look at U100 and U200, it looks like it's getting close to 50. So the long run value, if we try like U250, that should give us 50. So that means we found the long run value here. So our long run value is going to be at 50. So now we're going to take this same example and we're going to show you the algebraic way to find it, okay? So if we look back at that calculator thing, when I found 200 and 250, they were all the same. Anywhere above 200, it looks like is going to be 50 because it's reached its long run value. So you're going to take the recursive routine. The starting value doesn't matter. So I'm just going to take this part of the recursive routine. And I'm going to change the un and the un minus 1 to the same variable because in the end, they're going to be equal. Okay? So I'm going to make them x and x. So same exact equation, all I've done is changed it to un and un minus 1 to x. And now I'm going to solve. The tricky part is many of you forget that this is really a 1x. Okay, so I'm going to subtract now 0.8 from both sides. Okay, these cancel out. And remember, this is a 1x over here, so I'm left with 0.2x equals 10. And then to finish solving, I'm just going to divide by 0.2, and I get my long run value of 50. So it just took a little bit of solving to get that, okay? So now what I want you to do is pause the video and see if you can plug this into your calculator and find the long run value with your calculator, okay? All right, so I'm going to go to y equals. I'm still starting at u1, so that first part's going to stay a 1. I'm going to change this to 0.25. And if you've forgotten, you accidentally delete the, I'll show you how to do it again in case you delete it. Second 7 gives you the u. Parenthesis, the n is next to alpha. And it needs to be in parentheses. Don't forget to close your parenthesis. And then plus 150. And then don't forget to change the un min, which ours is starting at 100. And again, I could look at the table and see my values, and I can look right here. I can already see the long run value is 200. So that's nice. We could also look at the graph. And ours isn't showing up because our window's too small, so we're going to change the Y scale to up to, we already saw the long run value was like 200, so I'm going to change it to 210. And we should be able to see it now. Yep, you can see it right there, the long run value, okay? All right, so then the last thing is hit second, quit, get back to your home screen. We're going to hit second 7, 6, second 7, oopsie, I forgot the second, 100, second 7, oopsie, no, and second 7, 200. And the reason I pick big numbers is because you know the long run value is going to occur at some point. This one occurs quicker than some, but some of them don't occur till 200 or the 300th time. But we can see that our long run value is going to be 200 now. Okay, so let's look at that algebraically now. So again, the only part we're concerned with on the recursive routine is the bottom part. We don't care that it starts at. The starting value never impacts the long run value. It just might take you longer to get there if you start at a different one. So the first step is to change the un and the n minus 1 to x. So I've just changed them both to x's. And remember, this is a 1x over here. So now I'm going to subtract 0.25x from both sides. And I'm left with 0.75x equals 150. And the last step to solve for x is to divide by 0.75, and I get my Lagrange value of 200. Okay? All right, go ahead and pause the video and try these two on your own. All right, so your first step should change it to x. Second step, subtract 0.6 for both sides. Again, these cancel out. Third step, you get 0.4x equals 100. Last step, divide by 0.4, you get a long run value of 250. Now the second one's a little tricky. I get x equals 0.8x, subtract 0.8 from both sides, and I end up with 0.2x equals 0, okay? This isn't a shifted geometric sequence. It doesn't have the added on portion. So these geometric sequences are always going to go to 0 because 0 divided by 0.2 is still 0. So when it doesn't have this added on portion over here, okay, it's going to go down to 0 or go up to infinity. And most times if it's decreasing because it's 0.8, it's going to go down to 0. All right, and the last problem is the word problem. So same idea, just you have to read it and write the recursive routine. So Bob stocks the new iPhone 7 in his store. He starts the month with 200. So right there, I know that U0 is 200. And I know it's U0 because it says he starts the month. It doesn't say at the end of the first month. Each month he sells 45%. So if he sells 45%, that means that it's going to be 1 minus 0.45, which equals 0.55. That's how much he's keeping. Okay? So my recursive routine is going to be un equals 0.55 un minus 1 plus 45 because each month he gets 45 new phones in stock. So to find the long run value, I set them both equal to x, un and un minus 1. Subtract 0.5 from both sides and get 0.45x equals 45. And then divide by 0.45 and get a long run value of 100. Okay? All right, so your homework tonight is going to be worksheet number 3, long run value. Make sure you pull that up on Google Classroom and check your answers there when you are done. If you finish everything, that should be the only reason you pack up. Have a wonderful day.